So the last thing that I would like to cover in this Unit 3 is graphics for multivariate data. And you've seen in Lab 2 already that we do quite a bit of customizing our ordinations. Another thing that we also already tried is to cram as much information into our ordinations as possible. And we've already done quite a good job with minimal customizations. But you can do even better. So we can use shapes, colors, and sizes to highlight certain aspects, to highlight important variables. So I want to show you how that works. And finally, I should mention it's not very efficient to try to program everything in R. So sometimes you're much better off touching up your graphics outside of R. And have a little tutorial on how to do that as well. So that's primarily for your projects. So there are 3 labs that correspond to these things, and many of you may be familiar with this. So this is basically just about the plot function in R, what the syntax is for colors, shapes, symbols, sizes. Then this one here, that's a little bit more advanced. So it shows you how you can use colors, shapes, and sizes to represent additional variables. So I give you an example here out of that lab for a high data to ink ratio plot. So what that means is that you have a lot of information that's crammed into one graph. And that's an art that's appreciated by scientists. I can demonstrate to you how effective this is. So I can tell a story about my experiment around this graph. So I can say that I studied volume versus density of trees. So my general result here is that the faster the growth, the bigger the trees, the lower the density. And that relationship is actually observed across 3 different ecosystems. So we go here from a montane one with very high densities, mid-elevation to a low-elevation ecosystem. So this holds true across different ecosystems. It also doesn't seem to matter which species I look at. So this trend does look the same for the circles here, which represents one species, and the squares, which represent another. And this also seems to be age class independent. So even different age classes, which are represented here as a size of the symbol, don't break that correlation. So a very strong and pronounced result that I found here. Okay, so if you present something like this in a PowerPoint presentation or in a paper, that is very effective communication. I could probably show you 8 or 10 graphs that show all these elements separately. So I could have different graphs for different ecosystems or for different species. I could have all kinds of other relationships. So I could look at density over age, and density over volume, and volume over age in different ecosystems. So if you have a presentation like this, you flip through one graph after another, and the audience just keels over, right? Because they can't adjust, they can't take that in so quickly. So there are just too many things that are disconnected and that you can't keep in your head at the same time. But if you have it all in one graph, and you use symbols, colors, and even lines or functions to add additional information, that is really the art of presentation of quantitative data. So if you do your projects, I encourage you to think about it, how you can do this. So we'll help you figure this out. And then last but not least, 3C is touch up. And just so you know how you can use these things, I'll just show you some really cool examples by students who previously took this class. They're better than anything that I could come up with. So this one here is from a student who did a fish study, and rather than having boring labels here, she actually put the pictures of the fishes to describe the vectors here. And then colors and shapes are used for the types of lakes that she investigated. So this can be a little overwhelming. So one other thing you can do is break those graphs up and go through them step by step. So maybe we want to talk about different groups of fish. So here's the first, then we add the second, then we add the third, and then the fourth general type of fish, and discuss how they are affected by those different treatments. And those graphics touch-up skills are actually also handy, not just for your results, but also for your methods. So you can show how you collected your data, how you put transects in, where along the transects you caught the fish. So these are powerful ways to convey to an audience what you did and how you did it and what your results are. So that sort of graphical excellence will get you places in conferences, job interviews, presentations. So this course is also an opportunity to practice this a little bit. So this week we only have a really short multivariate statistics lab on factor analysis, which is also nothing new. It's just a follow-up to give you a little bit of time, depending on your background, to acquire some of those graphic skills here. What you can do in terms of graphics touch-up. And this really is an illustration of the principle, so I'm not going to do anything fancy. In fact, we're starting with a really simple plot here that I want to change a little bit, but I don't want to do it in R, so some things are just simpler to do in a graphics editor than in R. Other things are actually quite easy to do in R. For example, if you wanted to rotate all these numbers here, that's kind of a pain. So we could very easily do this in R just by adding the last one here. So then everything is oriented nicely. And maybe I want this a little narrower. That looks pretty good. So let's say this was our final graph that we want to touch up. So rather than putting all the labels and everything on in R, we could also do this in PowerPoint or another editing program. So I'm going to save this, and I'm going to save it in 3 formats that are quite good to use. So the first one is Windows meta file. That's good because we can edit it in PowerPoint. So let's do this. Call this. The next format is going to be PDF. PDF is great if you're a Mac user. Usually you have editing tools within your Mac ecosystem that can edit PDFs. For example, Adobe Illustrator is perfect for this. If you don't have that and you don't want to pay for it, you can also use Inkscape. Inkscape is good. Inkscape can also use the PDF file and then convert it into other formats in case you want to edit it in other programs. Inkscape is an open source alternative to Adobe Illustrator. And so let's save a PDF. Let's call this also bar. And finally, let's save it as a PNG. A PNG is just a bitmap. These are all image raster files. So they are low resolution, but they are perfectly good for a website or for a PowerPoint presentation as well. The editing works a little differently there, and I show you that as well. So let's save this as a PNG. And the reason I use PNG, that's the best format for graphics. So it's a compressed format. It's a small file size. Bitmap and TIFF, they are simply bigger file sizes, but they have no advantage, so they're uncompressed. And JPEG is a lossy format, so even if you say 100% quality, it's actually not. So you always lose quality, and it's actually designed for photos, so it's really not a good format for graphics. So stick with the PNG whenever you want to use something to put in your PowerPoint or or on a website. The other ones here, PDF, PostScript, and Metafile, those are vector graphics. And so those can actually be very flexibly edited, but they also have their limitations. For example, they're not really good for websites. Good, so that's it here, so we can close this up. And here are all my files now, so we can look at the bar chart. And you can see this is a high quality render. So we can maybe zoom in here to 1600%. So everything is rendered perfectly. Now if we look at let's open this in Paint. If we look at our raster image, let's see if we can zoom in here. This has not nearly the same quality, so it's a rasterized image. That looks good for some parts, but as soon as you have curves, they're basically just represented as pixels, not as real curves. And I also can't really edit it. And then our meta file, that one we actually have to put into a Word document. So let's create a new Word document. So it's a vector format that that is designed for Microsoft Office products. So you can put it in PowerPoint slideshows or in Word documents. And if we zoom in here, you can see this is also high quality, completely lossless, and it's editable. You can just not save that. And let's also create a PowerPoint file now. And let's put this into our PowerPoint slide. We can just clean this up and drag this meta file in here. It looks a little weird, so we have to crop it to size. I'll make it a little larger. But as you can see, everything is in good shape. So we can also edit this here. And in order to edit it, you can't actually select anything. So what you have to do is to go to Group, Ungroup, and you have to actually do this again. Group, Ungroup, and now everything is separate and editable. Now you still have to get rid of this outer frame here to get to the elements below. But now we can actually work with this. We can select every individual element, change it, change the font size, add labels. Just going to grab all of these and move them a little bit up with the arrow keys and maybe a little closer. That's great. We can probably also insert some text boxes here. Let's say this is my control, and I can choose my font size, Arial, and a little bigger. And we can obviously move this where we want it. And let's do a couple more. So let's call this one fertilizer 2 times, and copy this and put this here, fertilizer 4 times. So we can see that more fertilizer is actually not necessarily better. And if we want to highlight our fertilizer treatments, we could just use a shape fill here and say, okay, let's give this color. And since this is a stronger level of fertilizer, let's give it this color. And so that way you can very easily modify everything and create really unique graphs, which would be super complicated to program in R, right? So don't necessarily waste your time in R when you can do things in PowerPoint so much easier. And of course you can add titles and labels here. So I don't know, we can do a quick one here. So this one, let's call this yield in kilogram per hectare, and we can rotate it any way we want. And there we go. So now we can bring this back to Word. So the way this works, we're actually going to keep it as a meta file because that is the lossless format that we want. We can go save as, and we're going to pick Windows meta file or enhanced meta file. I don't think it matters. I think the enhanced meta file is slightly better. So let's call this one bar edited. so only current slide. If you have to submit something to a journal, they often want to have these things in, because they all work with Adobe Illustrator, they like things in PDF format, so we can certainly do this here as well. So let's save this as a PDF bar edited as PDF. So that's great. Again, we have the full resolution, nothing gets sacrificed here. Everything we edit is also is print quality that's preferred in the Apple ecosystem as well. And let's do one more. So if we want to save this for our website, we can also save it as a PNG. So that's right here. So let's call this bar edited. And what else? Let's also save it as a JPEG, just to show you what a bad idea this is. So let's save it as a JPEG file, bar edited. Slide, and we're done. So we have touched up our graph to the final way that we wanted, and saved it in all kinds of usable formats. So let's look at our work. So we have these in all kinds of different formats now. Let's start with a PDF. So that's certainly a very nice and high quality piece. So you could upload that with a manuscript. For our vector graphic here, we actually, so this is for inclusion into a Word document. So I'm just going to open this empty Word document again, and we're just going to drag and put it in here. So also this one, if we zoom in, that is the highest quality, so that's good for a thesis, or if you prepare a manuscript where everything is included, then you can do it like this. So that looks great. You probably want to crop it so that it's just the size that it needs to be. So there it is. So let's save this. So this is how you bring high quality customized graphics into your thesis documents or reports. And then last but not least, let's take a look at the JPEG and at the PNG. So if we open the JPEG in Paint, that's something we can do. And you can also edit it here, but especially the JPEGs, they are kind of difficult to edit. For example, if you wanted to change the color here, let's try this. Let's pick a green color and fill it. That doesn't work. You see basically the compressions here, they change the colors. So it's not a good format to work with. It's also not high quality. So if we zoom in here, this has all kinds of artifacts. I don't know if you can see that, but it really does not look very pretty. So JPEG really is not a format that you should use for graphs. This is strictly for photos. So I'm going to delete it. So the right format here is a PNG. Open with Paint again. And so let's try this again with a fill tool. Let's say we want to make this a light green and this one a dark green. So we can edit, obviously. We can add text. Fertilizer trial. Oh, yeah, I can change this. I can make it bold if I want. I can change the size. So this is also all possible to do in an editor like this. You can also move things around. So once you use it, it's immediately converted into an image. So you can't further edit it. So you can only do new things. But you can't select certain pieces and move them around a little bit. So that is possible. Also here our fertilizer, maybe they're not quite centered. So we can move those around. But all of this is now converted into a raster. You can see it here. This is all rasterized, and you can't further edit it. So that's a disadvantage. So if you don't like something, you actually have to get rid of it with the eraser tool and do it again. There we go. Okay. So once you're happy with everything and you want to upload it to your website, what you do is you want to crop it to just the dimensions that you need. Let's see, where is this? Oh, we have to select an area that we want. So maybe this, and say crop and save. And now this is ready to be uploaded to your website. And so while there are advanced editing tools like Adobe Illustrator or Inkscape that allows you to do more complex things, I recommend you just stick with PowerPoint and these couple of formats here that I showed. That'll go a long way. You'll be able to produce top-notch quality graphics for PowerPoints, for manuscripts, for theses. So nothing can really hold you back there. So this is a good tool set that you can use to pretty much get anything done.